Sir, kindly share your presentation.
Okay, so thank you, Professor Srinivas, to giving me the opportunity to present my lecture in this FDP program. Okay, so you have introduced myself. Okay, so I can start my lecture. Okay, so I will talk about the polygeneration system for the household application. So if I see that what we need nowadays, so uh, many places where the grid electricity is not available. So for that case, we need the off-grid electricity for the household application. So for that case, the many renewable energy sources may be the one option, and the small scale power generation system, that may be the solar based PV system or any other system which we can install in the rooftop of the house. So that can be applied for our electricity requirement. As well as in the summertime, we need the cold cooling system or air conditioning refrigeration system, and in the winter season we need the hot air or the heating of room or the hot water. So these are our some requirement, and as uh, many places, so that the places near the sea where the normal water is the that salted water, so we need the fresh water for the household application. Similarly, some remote area or that may be the hilly station, or that may be the island, so where the normal water or groundwater is not available, so we need to distill that water and we can prepare that water for our application. So for that, those conditions, that desalination system is also very important. Okay, so that if we consider the some house where which is at the remote places, so these are our requirement. Like the in a summer season, we need the electricity, cooling, and the fresh water. In the winter season, we need the electricity, heating, and that fresh water. So these are the primary requirements. So how we can use the renewable energy system to make that some sustainable system or household system or rooftop system, or maybe the small scale system which can supply our basic requirement to the community or small village or small town like that. So that type of system needs nowadays, that is needed many cases, and for that case renewable energy may be the one of the uh, basic sources that we can use for those applications. So that's why some of the action plan which has been taken by the Indian government for the sustainable development, and how we can going towards the renewable energy system. You know that the normal energy system or coal-based power plant that has been nearly banned in USA and in India. That is nowadays, that is the shared the measured production of the electricity. But in future, we have to think about that how we can go for the renewable energy sources for the various applications. So that's why a lot of action plan has been made by the Indian government, and the main purpose is to that how we can utilize the renewable energy for uh, our requirement. So like in USA, we can see nowadays that the coal-based power plant is nearly that shut down. So, and that wind energy and that nuclear energy and the solar energy, these are the major sources nowadays for the electricity generation. So that's why we have also go for that renewable energy system, and what are the different sources that we are nearly aware about, that the solar energy, wind energy, biomass energy, and hydrogen energy. and the hydropower energy and ocean energy, geothermal energy. So all the energy system has some individual advantages and disadvantages. Like solar energy is available everywhere, but this is the intermittent sources of energy. Wind energy, that is very much unpredictable and also not available everywhere within that range, which range we want. Biomass, for this case also, this is the limited sources. These are limited sources. Hydropower, that is depending on the place to place. Hydrogen energy, nowadays, this is the uh, growing energy sources nowadays, and we are many not only the power generation, we are also that consider the transportation system. That system also going for the hydrogen energy. So this is the one of the future energy where nowadays considered. Ocean energy, this is also limited. Limited to the ocean, and that so a lot of difficulties are there for that also. So that is not available every places. Geothermal energy has limitation that this is not also available everywhere, and also the temperature is very low. So geothermal energy cannot be used for the high temperature power generation system. Okay, so normal heating and cool heating application, we can use the geothermal energy. So every energy has some advantages and disadvantages. So although the why the solar energy, because this is available everywhere. Okay, but to take care about the intensity nature of the solar energy, that is also nowadays that emerging research field. Okay, so that's energy storage system we have to design and we have to use with that solar energy, and with the energy storage system, that system may be the very suitable for many applications. So that's why I am limiting my lecture to the solar energy. So solar energy based multi-generation system that I will discuss. So there are some data. This is for India, that how we are going for the renewable energy and what is the present condition, what will be the future. So that if we see that what are the different share of the renewable energy, so nowadays 52.5%, that is the solar. So that solar application is very high in India if we compare the many renewable energy sources in India. So that solar energy is the mostly used technologies or energy systems which are using in India. And what I have already talked about, that what is the temperature range, because when we are talking about the power generation applications, so that temperature range of the energy sources or renewable energy sources, that is very, very important. So based on that available temperature range, we can apply, because the different applications may need the different temperature. Like if you go for the Brayton cycle, we need very high temperature. If we go to the Rankine cycle, then we can need the temperature maybe 400 degrees centigrade. If you go for the other low temperature energy systems or the power generation system like organic Rankine cycle or many other cycle nowadays which are available. So for that case, we need comparatively low temperature range. So the depending on the temperature range, we have to design the energy system, that we can how we can design that energy system for the applications, and what type of energy system we can use for the temperature range. So that solar energy, very interesting thing is that solar energy that has a very high temperature range. So depending on the solar collector, we can get the different temperature. So that I will discuss later, like that flat plate collector, we get the very low temperature. Evacuated tube collector, we can get the better higher temperature. Then concentrated collector, like that. So depending on the solar collector and different solar collector technology, which will give the different range of temperature, and based on the temperature range, we can design the energy system. Or maybe if you want to use some energy system or the power generation system, and what is the temperature need for that power generation system, and based on that, the solar collector we have to select, like that. Okay, so and geothermal, that comparatively less temperature. So that is, this is the another advantage of the solar energy, that the depending on our applications, we can select the suitable solar collector which can give the suitable or the required temperature range. Okay, so this is in general the overview of the polygeneration system. So that may be the solar base. So this is the that very general representation of the polygeneration system. So we can use the any energy source, that may be the solar energy or maybe the other renewable energy. But ultimately we need more than one outlet or more than one output. That may be the any of the combination of this electricity, heating, cooling, phase water, hydrogen, and maybe others. So depending, others means like the like syngas or any other thing. So the lot of generation may be possible, that within those generation which output or which generation we needed. Okay, so based on that we can design or we can develop the polygeneration system or multi-generation system. So in this lecture, I will discuss about the three output. One is the cooling, another heating, and the desalination, and obviously there is a power generation. So that may be the combination of the power generation, cooling, or desalination, or maybe the combination of power generation, heating, and desalination. So in this respect, that the cogeneration, that terminology, that is very old terminology, and that has been used with the power generation system. So that what is the basic difference between the polygeneration or multigeneration with the cogeneration? So cogeneration means that you have a single generation system, and apart from that you need the other type of generation, so that will basically the core generation. Like for example, you have a power plant, and to use the waste heat of the power plant, we can use the like any refrigeration system, let's say the vapor absorption refrigeration system. Okay, so that the cooling product of that system, that is basically the cogeneration system or cogeneration. So with the main generation, there is a bypass or the byproduct of that system. But when we're talking about the polygeneration or multi-generation, for that case, every output is very important. So when we design that system, so you have to design the system based on the what are the outputs in units. Okay, so and I have talked about that the solar energy, to avoid the intermittency of the solar energy, we need the energy system, energy storage system. Okay, so that's why I will also focus the energy storage system for this lecture. So there is the different terms or subsystem for the polygeneration system, which I will like to discuss. That is the solar collectors, energy storage system, power generation system, and cooling system, and desalination system. So this thing nowadays very emerging technologies, because that solar photovoltaic cell, that is very mature technologies, and this is used everywhere nowadays. Okay, so this is very common technologies nowadays. So but many cases when we will need some heating output from that PV cell, because the PV cell efficiency may be 20%, so 80% is basically wasted. So how we can use that waste energy for our other purpose? So for that case, we can design the photovoltaic cell with that thermal collectors, thermal solar collector also. So that means we can get the electricity, both the electricity and the heat from that system. So that is the basically the combination of photovoltaic cell and solar thermal collector. So this is PVT. So PVT technology is a very emerging technologies nowadays, and simply PVT technology, that is called like that. Sometime that from the PVT, that because the solar PV cell is generally the flat surface. So obviously when we'll incorporate the solar collector with the PV, so that is just like a flat plate collector. So that's why the temperature output by that flat plate collector or the PVT system that is comparatively low, and that temperature maybe always less than 100 degrees centigrade. So that heat we can use some heating purpose, but if you want to go that to run some refrigeration system or power generation system by using that heat which are getting from the PV cell. So from the PVT, that is not possible. So that's why sometimes we can use the, instead of PVT, we can use the concentrated PVT. That means the concentrated photovoltaic cell with the concentrated collector. So for that case, we can get the higher temperature. So then we can use that heat output for the high temperature applications, that may be the refrigeration applications or maybe the low temperature power generation system. So when we will want to install or for any multi-station system, if you know the electricity, you need the electricity from the PV cell, and if you want to use that PV cell or PVT device to produce the cooling output, or that means if you want to run the refrigeration system, so for that case we have to go for the CPVT, concentrated PVT or concentrated photovoltaic thermal system. Okay, so in the earlier lecture also people has discussed very details about the different type of solar collector and how we can tracking the solar energy, solar tracking system like that. So just I am briefly want to say that what are the different type of solar collector which is available, and I have already told that depending on the solar collector or collector system, your the output temperature range that is different, or if you want to get the temperature depending on your application, you have to decide what is the temperature range you need, and based on the temperature range you have to select the solar collector like that. Like that flat plate collector or non-concentrated collector that has a temperature comparatively low. So that like flat plate collector that can be used only for the heating purpose. If you want to run the refrigeration system, that is not possible with that. The EV, you have evacuated tube collector ETC or CPC. For that case, we can get slightly higher temperature. Okay, so for that case, some refrigeration system you can run, but the power generation system that is slightly difficult to run. So we have to go for the concentrated collector if you want to get the higher temperature. Okay, so what I want to say that depending on the temperature range, you have to select the solar collector. Like let's say solar tower that will give the very high temperature. So if you need very high temperature, let's say more than 500 degrees centigrade, so we have to go for the solar tower. So what is that applications? Application may be that the Brayton cycle. So if you want to run the Brayton cycle by using the solar energy, so we have to go for the solar tower like that. So depending on temperature, PVs, that other type of collector that will also give the considerably higher temperature, but not so high. So within all type of solar collector, I can summarize by this way that if you know the minimum temperature we will get by the flat plate collector, and maximum temperature that we will get by the solar tower. So what I have already told that there is a intermittency of the solar energy. So to avoid that, we need the thermal energy storage. Okay, so that thermal energy storage may be the three types. One is the sensible, that is basically depending on the specific heat capacity of that material, like that water. We can use sometime as a heat reservoir because the water CP is comparatively higher as compared to the other liquids or other systems. So that is just like a sensible heat storage system. And next is the latent heat storage system. So that latent heat storage system, that storage capacity is higher. And for this case, advantage is that for the constant temperature there is a heat transfer. So if you, for some application, if you need that you need the temperature control, or you need the constant temperature application, so obviously you have to go for the latent storage application. And nowadays this has a very emerging and booming technology, that phase change material, which we say that different type of phase change material that is used for the solar storage or solar energy storage applications, which is basically called the latent heat storage. And last one, this is the comparatively new as compared to these two, that thermochemical energy storage. So that the first storage system that is depending on the specific heat capacity of that material. Second one is the latent heat of that material. Third one is basically the chemical storage. So there is a chemical reaction. So that may be the exothermic or endothermic. So during that process, there is a storage, the absorption of heat or the desorption of heat that is there. So in the that bottom three figure I have given to understand that how that the heat storage, energy storage, that is during that process there is a temperature change. So that is for the sensible case. For the latent heat case, we can see that the temperature is constant. And third case, there is a temperature change. Okay, but the capacity is high. Okay, so obviously that latent storage that will only give the constant temperature, but for the thermochemical and sensible both cases, there is a temperature change during the energy absorption and desorption. But for the thermochemical storage, that the capacity or the amount of energy stored or absorption desorption, that is comparatively high as compared to the other type of energy storage. So this is, that's why this is nowadays much more promising and booming technology, emerging technologies. And that power generation system. So all these power generation cycle or power cycle that can be used for the use with the solar energy application. So what I have already told, that let's say if you want to run the Brayton cycle, so for that case we need the solar tower. Okay, for this application, because for this case we need the comparatively high temperature. And nowadays that Brayton cycle is used, that is very emerging technologies, because the battery cycle is used generally the nuclear power generation system. And nowadays, apart from the helium-based battery cycle, the supercritical CO2 battery cycle, that is very new and in the emerging technologies, and that can be used with the solar power sources, or also with the nuclear power nuclear energy sources. And that water Rankine cycle, this is the established technologies, and for the solar applications, you can use that water Rankine cycle. But although present water-based Rankine cycle are basically based on the the coal power based system, or coal energy based system. But that for the solar energy, by using the solar energy, this type of power system also can be developed, and maybe in future on is that possibilities is that that we can use this cycle. Okay, so that organic Rankine cycle, Kalina's cycle, supercritical Rankine cycle, organic fast cycle, and trilateral fast cycle. So there may be the very many applications. So the first one is the high temperature application. Second one is the medium temperature applications, and that list of that energy cycle, that is we can use for the, in general, the low temperature or low medium temperature applications, maybe up to 200 maximum degree, 200 degrees centigrade. So these are some options are there. So we can, where we can use this cycle. So in general, that that solar energy may be two type of applications. One application may be the that power generation system or plant, solar power generation plant we can use. So a lot of that. So that is the other another plant and another position, another location like that. But another option is that when if you install some small scale system like the rooftop system, so for that case, obviously we will not go for the Brayton cycle or water ranking cycle. For this case, because this temperature is range is less, so obviously we will go for the organic Rankine cycle, calendar cycle. So this type of cycle we can use. So any rooftop system for a building, if you want to install some power generation, so we can go for this type of cycle. So now one question maybe arises that that PV technology is already available and that is the mature technology. So how you will go for the this type of power cycle? So you know that the power cycle for the same temperature range, the thermodynamic power cycle that will generally give the higher efficiency as compared to the other electricity generation system that may be the thermoelectric generator or maybe the PV. So still the thermodynamic cycle has the higher efficiency. Although in future we don't say that because a lot of research is going on the PV cell that how we can increase the efficiency of a PV cell, and there is a different type of generation, first generation, second generation, third generation like that. So that PV cell efficiency that is continuously increased. So maybe in future we may not go for the power thermodynamic cycle, we may go for the PV system like that. So that future will tell that which direction we will go. But these are some options that we can use for the low temperature application, low temperature solar application. So here some economical comparison are there because I have already told that for the low temperature applications, lot of options are there, not only one option. So there may be the comparison within that and which technology we will go for and that which cycle we select for that application. So that in that lot of advantage and disadvantages are there for the different cycles. But WRC technology, organic chemical technology, that is comparatively old, very old technology, and that is nearly mature technologies. Although in India, that technology is not using or that is not mature nowadays, but in developed country, that is the mature technology that is used in many where. Okay, so that WRC is the one option, but apart from this, there are the another cycle, and every cycle has some advantage, disadvantage, which I have listed in this table. So that trilateral plus cycle or the organic plus cycle, Kalina cycle, and CO2 Rankine cycle. So everyone has some limitations. Okay, so everyone some limitations and advantages, disadvantages. So based on your applications or requirement, we can choose the suitable power generation system. So obviously there will be the competition in between the thermodynamic cycle or the PV system or thermoelectric generator. So similarly, there are many depreciation cycle which we can use for the polygenation, solar-based polygenation system. So and many cases different that research paper, if you see that the people has used the different type of depreciation system along with the solar based system. So for the polygeneration application, so vapor compression system. So first three system are basically the electricity generation system. So when we use the refrigeration system with the solar based system, so there are two options. One option is that we can use some electricity generation system to produce the electricity, and that electricity we can use to run the refrigeration system. That is the electricity based refrigeration system, like the vapor compression system, thermoelectric system, refrigeration system, or magnetic refrigeration system. And second option is that directly we will use the heat we are taking from the solar energy. That heat we can use for the refrigeration system to produce the cooling. So that is basically the heat-based refrigeration system or heat-driven refrigeration system, like the vapor absorption system, vapor adsorption system, and ejector refrigeration system. So there are a lot of debates that which refrigeration system will be the most suitable for the certain application. That is basically based on your applications. So everyone has some advantage and disadvantage, and people are working on all the possibilities. Okay, so although if we compare with the different type of system, then you know that the vapor compression system and thermoelectric system and magnetic radiation system, every one has some advantages and disadvantages. So you know that the vapor compression system is widely used, but thermoelectric refrigeration system just limited for the very small scale, small applications or very limited applications like the electronics cooling and medical application. Magnetic refrigerator or refrigeration system nowadays that is available for the household application also. And vapor absorption system is slightly old technologies, and vapor absorption is also not old. That is the new technologies, but both cases there is some problem or some limitations are there that absorption and desorption process. So that's why the ejector application system, which is the heat driven system, and this is much more emerging as compared to the vapor absorption and vapor absorption system. So if we see the literature that for the polygenesis system, what are the refrigeration cycle people has used. So you can see that the most of the cases the ejector has been used, ejector and vapor absorption system. Okay, so maybe people has given the ejector refrigeration system as a first priority. Okay, so similarly for the power generation system, if you see that the all type of power generation system which I have discussed. So till now, if you see the paper or research paper related to the power generation system, then people has mostly used the ORC for the power generation application, apart from the that PV. Okay. So PV is most reliable because PV has very lot of disadvantages as compared to the thermodynamic cycle. So may people mostly use the PV system for the electricity generation, and some cases ORC. And second priority case is the ORC, organic thermal cycle as used. So now next I am going to the desalination technologies. So water distillation system. So there is lot of classification, lot of technologies are available, and question is that which technology you will use and which technology, and maybe that the different technologies depending on the your situation, which situation you will want to use this system. So within this, in general, that some this is the evaporation condensation. This is the mechanism. Based on the mechanism, we can get the three type of groups: evaporation, condensation, filtration, and crystallization. Uh, like the normal solar steel. That is basically the based on the evaporation and condensation. Filtration, like the reverse osmosis or RO system, which is generally used nowadays in the household application, or mostly used desalination system in the for the household application. Okay, so and there may be some another difference is that based on whether some technologies are based on the simple the electricity, and some system are based on the that is the not depending on the electricity. So simple heat we can use. So that means the desalination system also can be classified by this way, that one systems which is based on the heat driven system, another is the electricity driven system. So when we'll use this type of system, RO system is generally used for the household application because we have electricity. But if you want to use that some system where there is no electricity, or we don't want to use the electricity, so for that case we have to go for the evaporation condensation systems like the solar steels. Okay, so solar steel this is basically the heat driven system. So directly we can use the waste heat or the solar heat for this process. So the more details about the solar steel is that the solar steel, this is itself a very that the wide topic, or lot of research uh, has been done, and nowadays also a lot of researches are going on that solar steel. So that solar steels can be classified based on the different basis. So on basis, maybe the what type of energy sources you are using, heat sources you are using. So based on that, that may be the passive, active, or hybrid. Okay, so passive means that this is basically the solar fully based on the solar radiation. Active means that is not, maybe the not depending on the solar application. You can heat up that. So we can use the other energy sources for the heating purpose. And hybrid means both the solar plus other sources of heat. Or maybe the solar energy also can be, we can collect the solar heat and then we can circulate that heat inside that solar steel. Okay, or that this system can be directly take the. So here on example or the figure I have given, this is basically active passive type system. So this is fully based on the solar radiation. So lot of that researches are going on the solar steel, how we can increase the capacity of the solar steel, or because the solar energy is intermediate sources of energy. So how we can get the continuous output of the for that solar steel, or so we can use some energy storage system. And then when we are using the energy storage system like PCA, for that case thermal conductivity is very low. So we may go for the nano technologies or nanoparticle with that PCM, phase change material. Or maybe we can use the porous material to increase the thermal conductivity of that system. So we can use the combination of that porous material and phase change material to enhance the performance of the solar steel. So there may be various researches which are going on that solar steel. So another may be the what are the different type of slope, and how we can track the solar energy so we can get the maximum solar energy at a certain time. Okay, so these are also the various research field which are related to the solar steel. So that when I'm talking about the power, so power heating and desalination, that is not so very difficult, because power and desalination makes purpose, and heat we can easily get that waste heat that we can use for the heating purpose. So that's why the main challenging is that in a summer season, power, cooling, and desalination. This is the main. So that's why I am concentrating on this issue, not the heating issue. That heat we can easily get. Okay, but for the cooling, that cooling we cannot easily get. For that case, we have to use some cooling technologies or the refrigeration cycle. Okay, so that's why I'm focusing on this issue, that how we can combine that power, cooling, and desalination. So that's why I have used the different technology for the power generation. I have discussed the different technology for the cooling application, and I have discussed the different technology for the desalination applications. Now, how we can integrate these three type of system, and what type of power system, what type of cooling system, and what type of desalination system you will use with the solar energy or solar energy based the multi-generation system, that is up to you, or that may be depending on the on that conditions. Okay, conditions your application. So based on that, you have to choose the different sub component of the polygeneration system. So that may be combination of the photovoltaic cell, and that what is the electricity we are getting, that is we can use for some mechanical cooling system. That means the electricity based cooling system. That electricity based cooling system means the vapor compression system or magnetic refrigeration system, or maybe the thermoelectric cooling system. So these are the electricity based or mechanical cooling system. So So we can use that the electricity generated for the PV that we can use for the vapor compression system, and we can use the RO system, which is also again depending the electricity. So you have a PV, and this PV output of the PV that is connected to the vapor compression refrigerator, and that is connected to the RO system. So that means you are getting the electricity, cooling, and the desalination. So this may be the one combination or simplest combination. Okay, other combination may be the solar thermal collector we can use with that heat engine. That means the any power, the thermodynamic power cycle we can use, and we can use the heat driven refrigeration system, and we can use the heat driven desalination system like solar steel system. So maybe third combination, maybe we can use the concentrated photovoltaic thermal, and what is that thermal energy or heat energy we are getting, that can be used for the refrigeration system, the heat driven refrigeration system, and that heat also we can use to use for the desalination system, heat driven. So that means the solar steel. Okay, so there may be the another combination CPVT, then heat engine, then solar driven refrigeration, then heat driven desalination. Okay, so a lot of options are there. So like we can also use that CPVT with the RO system for the desalination, and we can use the heat driven system, or maybe we can use the heat driven refrigeration system like that. Okay, so a lot of combinations are there. So that is what I have told, that depending on the situation, depending on the applications, people can choose, and which is good combination, that is very difficult to say. Okay, but lot of combinations may be possible because you have a lot of options for the power, cooling, and desalination. Okay, so one of my study that I want to display here, which we have done, that is on combination that we have used the concentrated solar PV, and then that is integrated with the combined power, cooling, and desalination system. That means the thermal energy I have used for the power system. That means the ORC we have used for the power generation, again power generation. So PV also giving the electricity, and the ORC that will also give the electricity. So double electricity generation, and then cooling. That means I have used the uh, that ejector refrigeration system for the cooling output, and then I have used the solar steel, that means the heat driven desalination system for the face water application. So this is one combinations uh, I have studies, and this system we have designed by this way. Okay, so CPVT is there, and from there we are getting the heat. So that heat is used for the organic temperature cycle, which is basically drive the turbine, so we can get the power output, and then that is coupled with the vapor, that ejector refrigeration system, where we will get from the evaporator, we will get the cooling output, and again this is connected with the solar steel. So this solar steel is basically the hybrid type solar steel. So direct solar radiation is also there, and also the hot oil that also flowing through the solar steel. So this is one type of hybrid solar steel system. Okay, so this system is basically the that electricity generation, cooling, and also the desalination. That means the face water that is given. Okay, so which I have already discussed that, and some of the emerging working fluid that has been used. So because you know that nowadays when we will want to choose the any working fluid or any heat transfer fluid, then we have to see that what is the advantage and disadvantage is there. So mostly for the working fluid, so that means the refrigerant. So that the in view of the environmental concern, that global warming potential and ozone layer depletion, two are the very important parameter, and we have to restrict it, and we have to see that how that refrigerant which you want to use, that whether that is the environmental safety or not. So that is very important criteria. So like in a refrigeration system also, that depending on that global that environmental effect. So continuously we are in a changing continuously that the refrigerant is changing. If you see that previous 100 years, so what is the changing of refrigerant? So time to time that some of the issues are raising, and depending on that your refrigerant is changing. Okay, so presently that global warming or the ozone layer depletion, that is very important criteria for choosing the suitable refrigerant or working fluid for any solar-based polygeneration system. Okay, so if we considering these issues, then we can see that these are some refrigerant which are very promising, because for this case the ozone layer depletion is nearly zero or negligible, and global warming potential is also very less. Okay, so according to the UK regulation, that 150 global warming potential, that is the limitation. So always we prefer the refrigerant which has the global warming potential is less than 150, like that. So these are some environmental issues which should have considered to selecting the working fluid for the generation system. So these are some promising refrigerant, and this is some modeling part. So we have to separately model the CPVT, and then we have to model the ERC and WRC model, and then solar steel model. So all we have to club together to get the consolidated result based on the different environmental condition and define the solar radiation. Okay, so that some of the on mean operating condition data that is presented in this table. Okay, so for the given condition on and the given surface area for the PV cell, so what will be our outputs, that is given in this table. And we have done a lot of other that parametric studies also we have done, and also we have calculated the different component cost of this system. Okay, so these are some that parametric studies. So that I don't want to go to the details about this discussion. So because this you can get from the paper. So how that parameters, so that performance parameter, that is basically depending on the net overall output of that system. Okay, and how that is changing with the different operating parameters. So these are the some results which are given here. So many, and one interesting thing is that we have also studies based on the Varanasi weather data and year-wise for the different month, and for the average data of the different month, like the solar radiation, ambient condition, ambient temperatures. So based on that, how the performance of this system that will vary, that we have studies. So these are the some important finding what we have discussed. So basically, I am going to this topic, that what is the challenges. Okay, so question is that we can use the multi-agent system for the household application, and we can make that building as a self sustained building. Okay, so but this type of that if you see the commercial application, then that you may hardly, mostly you will not get any type of that multi-generation system which is nowadays presently available, because there is some, although theoretically we can see that a lot of advantages are there, and we can get the different output in a single pockets or single bags like that, but there is a lot of advantages is also there. So the practical advantages or the operational advantages, so that we have to taken care in the future research. So that the that intermittent and non-uniform solar radiation, so for that case people are going for the solar energy storage or energy storage system, and this is very hot topic. So how you can get the, although the solar radiation is changing, but ambient temperature is changing, because when we'll design a system, then this system will be designed based on the mean operating condition. That means which is called basically the design condition. Okay, but operating that ambient temperature is changing, solar radiation is changing, so everything is changing. So for that case, how we can operate this system for a mean operating condition? So that will basically the off design condition. So the system mostly run for the off design condition, and when any system run under the off design condition, we'll get the lower performance obviously. So that's why the when we'll design that system for certain solar energy or so that the one option is that the we if you use the solar storage, energy storage system, so that problem that up to many percent we can that solve this problem by using the solar energy storage. And second is the difficult to optimize the production plan according to the demand. Okay. So basically the time to time your demand is changing. If you use for the combined multi-station system in a house, so but in a whole day you will see that the somewhere you need the more cooling, more elect, somewhere sometime you need the more electricity, or that may be changing season to season. Okay. So some season you need the more energy, some season you need the less energy. So your one thing is that yeah, that the relay in that the which you can say that the total energy requirement that is also changing, and also the relative energy requirement that is also changing. Okay, so how we can optimize that system that will give the energy as per your total energy as per requirement, and relative energy as per in sometimes we need the more electricity, less cooling. Sometime you need the less electricity, more cooling, like that. So how that we can control by using the multi-generation system. Okay, so that type of this is very great challenging, or the most challenging for this type of application. Okay, and obviously when for this type of system you need a lot of space for the solar collector. So when we'll use the space for the solar collector, so obviously that has some other environmental effect, like you have to do the deforestation, and some of the habitats losses is also there. So that is also the another problem when we'll go for the solar energy system, because we need a lot of space for the solar energy. And then the solar collector, which I have told that the intermittency that we can solve by using the storage system, but storage system is very expensive. So that cost of the energy storage system, that is a issue that that's why this is also very challenging nowadays, that the we can use the solar energy storage, but what will be the cost? So cost effectiveness. So how we can design the system, solar system with the solar that collector and storage. So for the cost effective the solar system. So that is nowadays very challenging. So that's why the uh, solar energy storage, a lot of work is going on, and that is, but that the practical use of this system, that is uh, that is not matured nowadays. Okay, so that is also on issues, and obviously the research topic that issues are there. Okay, so and that polygenation system, that season to season, that variation is there. So season to season variation of your total energy requirement, and also the relative energy requirement. That means the what percent of energy you need for the cooling, what percentage of you need energy need for the that electricity appliance, like that. So that relative requirement, that is also, that may be also change, and total energy requirement, that is also change. So that issue I have already discussed. And another important issue is that that is the varies building to building. That means the if any company want to develop this system, then what capacity system they will develop. Okay, so because the building to building, that means the user to user, that requirement is changed. Okay, defined user need the defined capacity system. So that will create a problem for the manufacturer. Okay, so when any manufacturer want to develop this system, then that is very much unpredictable that they have to develop that system for the which capacity, what capacity. Okay, so and what is the control system that is required, that if that requirement is vary, how that system will be response with that depend variation of the requirement. So that's why for the manufacturer also this is very difficult to manufacture this type of system. So that's why, although we are talking about the multi-generation system, polygeneration system, lot of research is going on. But if you see what is the commercial status of this system, so then you will see that there is no commercial product. Okay, some cogeneration systems are available,
కిషోర్
but the
గుడ్ ఈవినింగ్. సారీ టు డిస్టర్బ్. ఇది జరుగుతుందా సెషన్? సో ఎందుకు చేసా అంటే ఇప్పుడు క్వశ్చన్స్ అన్ని ప్రిపేర్ చేస్తాం, సబ్మిట్ చేయాలని ఉంది.
Please proceed, sir.
Okay, so that's why the different issues and different challenges I have discussed. So obviously, that will open some research opportunities. Okay, so which we can do in this field. Okay, so obviously, in general, this field is very emerging research field. Okay, lot of research is going on in this field, and many journals are available where we can publish this type of research. So a lot of options are there. Many energy channels are there. So a lot of options are there. So this in that respect, this is very promising. And a lot of scopes now are still there. So these are the some research opportunities. Maybe this is not the limit, but some of them I have listed here. Okay, so that the need of hybrid energy sources for the peak demand. Okay, so because I have told that the solar energy storage or energy storage system, that is very costly. So if I go for the other energy sources apart from uh, the solar energy storage, to avoid the intermittency of the solar energy, then that will be the one option that we can instead of using the solar energy storage, we can use the hybrid energy sources. Okay, so this is one opportunities we can use. So that with the multiple energy sources or multiple renewable energy sources or other energy sources with the solar energy, how we can use those sources. So that is the hybrid sources. So how we can use the hybrid sources so that we can make the more efficient and more reliable that solar based multi-generation system. So that is one option is there, and you can see that this is the emerging field and a lot of research is going on this way. So you can use the hybrid energy sources. And then next one is the optimization, system optimization, compact design of the heat exchanger, compact design of the other system, so that we can save the space. Okay, so this is the one opportunities. Okay, system optimization to get the best performance and compact design to save the space. Okay, so this is the second very emerging issues and emerging field or opportunities for the research. And third one is the need of flexible design to all season and building use. Okay. So if we can use this system, and then we can use some control system within that polygeneration system, that we can easily control that flow, mass flow rate, depending on your application. Let's say, for example, you have a WRC and you have a refrigeration cycle, and you are using the same heat source. Then we can change the flow rate or relative flow rate in the for the refrigeration system and for the WRC, so that we can change the power output or cooling output, relative power and cooling output based on your requirement. Similarly, if the total capacity, how you can change, so that the flexible design. Okay, so flexible design by which we can easily change your the relative capacity as well as the total capacity. Okay, so that system is very much, this system will be very much reliable for the household application. So if I make that system like that, so that will be very useful. Okay, so in this way also we can think about that, how we can make the flexible system. Okay. Then another point is the need of development of cost-effective solar devices. So obviously I have already told that the solar devices means the, that is obviously along with the energy storage system, so that the solar collector and solar energy storage we can sometimes couple together, we can use the separately, but when we are using the solar energy, so obviously the solar energy storage is coming into the picture. So that's why the combination of these two, that how we can design that system very cost effective, or the how we can decrease the cost of the solar energy storage, so that your overall cost will be decreased and that system will be much more useful and reliable. So in that direction also we can think. So obviously that the energy storage, that the energy storage field, lot of research is going on, and people nowadays going for the thermochemical energy storage, because I have told that the thermochemical energy storage, the storage capacity is much more higher as compared to the other type of energy storage. So we can go for this. So uh, the reliable design and the compact design, so we can, which will reduce the overall cost of the system. So that is very important. So in this direction also we can think, and people are doing work in this direction also. Okay, so then the select of appropriate system components. So that a lot of possibilities are there. I have already told that there are many power generation systems, there are many uh, that cooling system, there are many power that desalination system. So how we can integrate the different system and different component, so that the overall performance of the system, that will be the best suited for the certain application, and this will, which is more reliable combination of the defined sub component of the system. So and how we can design that system, so that the number of component will be less. Okay, and the most effective component, and not like apart from this, that if you go for the single component like that heat exchanger, that may be the evaporator, condenser, whatever maybe. So for that case, that there may be the different type of heat exchanger. So for that case also, the which type of heat exchanger and what will be the optimum design of that heat exchanger. So that is also very, very important for any system. So not only the subsystem, that also the sub component is also very, very important. So we we have to when we will want to get the very best, what is the best system, so what will be the best suited power generation system or cooling system, and what is the best component, that means the which type of heat exchanger we will use, which type of expander we will use, which type of compressor we will use. So there may be the different combinations, so what will be the best combination. So in this way also we can think about that, and people also doing in this way also. And then last one is the uh, more development of the data-driven algorithm-based model. So you know that nowadays machine learning and artificial intelligence, these are the very hot topics. So basically the data-driven model, because that type of system very much depending on the environmental parameter. Environmental parameter, which is the most unpredictable parameter, like the solar energy, or maybe the ambient temperature, or maybe the wind energy, like that. So all the that environmental parameters. Okay, that is most unpredictable. So for that case, that the simple model or theoretical model or physical model is that is failed to predict the accurately this type of environmental parameters. So obviously for this case, the data-driven model is very important, and that will play a very crucial role in this type of applications where the parameters are very much unpredictable. So that machine learning model that we can use to get the that energy requirement pattern or the environmental parameter patterns to get the best design of the multi-generation system. So this is also very important field of this case, and people are also doing research in this way also, and maybe obviously this is also a emerging field of research for the multi-generation system. Okay, so thank you.
So thank you, Professor Sarkar, for your elaborative PPT presentation. On the behalf of everyone present, I would like to express our sincere thanks to Professor Sarkar for his elaborative presentation on solar-driven combined cooling, heating, power, and desalination for self-sustained houses. Dr. Sarkar, your talk was very informative and inspiring. You have shown us how solar energy can be used in so many ways to make home more sustainable by providing cooling, heating, power, and even clean water. So your research is great step towards creating homes that use less energy and are environmentally friendly. So we appreciate the time and efforts you took to share your knowledge with us today. Your work has truly inspired us to think about how we can make our homes more self-sufficient and sustainable. So once again, thank you, Dr. Sarkar, for your valuable insights. We look forward to learning more from you in the future. Thank you, sir.
Okay, you are most welcome. Thank you.
Thank you, Professor Sarkar ji, and thank you for accepting our invitation and sharing our presentation.
Okay, thank you. Bye.
Bye, bye.
Bye, sir.